Hi everyone, Ravi this side. Welcome to EnggAdda. Today in this video, we are going to discuss about one of the structural design pattern, which is adapter design pattern. This is the design pattern series, and in this series, we already have discussed about the design pattern. What are the different categories of design patterns we have, and we also have discussed couple of creational design patterns like singleton design patterns, factory design pattern, abstract factory, and prototype, builder. Everything we have discussed in this series. Here we are starting the structural design pattern, and the first design pattern that we are picking up is adapter design pattern. So if you are new to the channel, please subscribe the channel and please watch others design patterns to get more idea of what design patterns is and how we can design them. Okay, we have discussed everything in detail. In this video, we are going to pick this adapter design pattern. This is the structural design patterns. Let me try to brief what structural design pattern is, and then we can start doing analyzing the adapter design pattern, discussing why it is used and how we can use it out, and what it is. Everything we are going to discuss related to the adapter design patterns. So let me brief you about the structural design pattern first. So yeah, so here you can see we have different kind of design patterns categories like creational, structural, and behavioral. In the structural, you can see that this deal with the class and object composition. So this is what this structural design pattern is. Here we are going to discuss about the adapter design pattern, which allows incompatible interfaces to work together. So let's say you have one interface, or you can say let's say you have one class which is legacy class, and you have new other class, okay, and you want to communicate between these two legacy classes and the new class. Then you can think of adapter design patterns, and then with the help of adapter design you can make them compatible and make them talking. Okay, adapting a legacy system output to work with the modern APIs is one of the example of adapter design pattern. Okay, I hope you got the idea what it is, and I will go next to the adapter design pattern to discuss more about it. Okay, so here we are. Let me start from beginning. Sorry. Abstract, builder, everything we have discussed in the videos. So you can watch those videos. Okay. Now here we are on the adapter design patterns. So what is the adapter design pattern? The adapter design patterns acts as a bridge between two incompatible interfaces. Okay, I already have told you that. Let's say there is a legacy class and there is a modern class, and you want to make legacy class communicate with the modern class, then you can use the adapter design patterns. It will work as a bridge between both of them, enabling them to work together. It allows an existing class or the API to be used as if it has a different interface without modifying its source code. So this is what adapter design pattern is, and I will explain you with one of the example of the real time. Like, think of it like an electrical adapter that allows a 2-pin plug to fit into 3-pin socket. So let's say you have 2-pin plug and you want to plug that pin into this 3-pin socket. So there would be a difficulty, right? It is not good practice to do. So electrical adapter come into the picture, which has 2-pin socket and 3-pin plug, and that will act as a bridge between 2-pin plug and 3-pin socket. Okay, I hope you got the idea. The plug and the socket are fundamentally incompatible, but adapter mediates between them. So this is what adapter design pattern does. It will try to make two interfaces compatible with each other. Now why should you use it? So here is the reason that I have listed down, like incompatibility resolution. When two system or the components are incompatible but needed to be communicated, you can use the adapter design pattern. Reuse of existing code, use an existing class or the library in a new context without altering its code. There also you can use the adapter design pattern. Coming to the third point, which is flexibility in the system design. With the help of adapter design pattern, you can easily integrate third-party libraries of the legacy system into your application. Okay. And the fourth one is separation of concerns. Keep the adaptation logic separate from the core logic, adhering to the solid principles, especially the open and close principle. So these are the scenarios or these are the condition why one should use the adapter design pattern. These are the reason why one should use the adapter design pattern. Okay. Now I will go to the next slide to discuss when to use it. You want to use a class that does not have the required interface, then you can use the adapter design pattern. If you are integrating a third-party library or the legacy code in your system, you can go with the adapter design pattern. And your application, if your application needs to interact with the multiple APIs having different interfaces, then you can also use the adapter design pattern. Let me try to tell you. Let's say you want to have a payment gateway, or let's say you want to have a payment portal. Okay, and you are working with a payment gateway. Let's say there could be a different payment option that will be available. Like there could be a PayPal payment, or there could be a Stripe payment or Razorpay payment. Okay, but you want the user to do the payment through the payment gateway, and these payments like PayPal payments or Stripe payments or the Razorpay payments, they are not compatible with the payment gateway. Then the adapter come into the picture. This adapter will make this payments modes, or you can say payment tools, to interact with the payment gateway, and the adapter will work as a bridge between the payment gateway and these tools. So you can think it of like that. Okay, so this is what the adapter is, and this is when you can use it out. Now I will go to the next slide to discuss about the how can we use it. Okay, the real world analogy is payment gateway integration. Imagine you are building an e-commerce application that supports different payment gateways. Example, PayPal, Stripe, Razorpay. Each gateway has different interfaces, but your application expects a single interface. Then how you can do that? Using the adapter design pattern, we can achieve these things. I will take this as an example when we are going to develop this adapter design pattern, and I will explain you how you can do that. So I will go to the next slide to discuss how to develop adapter design pattern. Here you have to define a target interface, the common interface expected by your application. Let's say you have created one payment gateway, and with the help of payment gateway interface, you want to do the payment. Now these classes like PayPal or Stripe or the Razorpay, they have different methods for the payment which are not compatible with the payment gateway. Then you have to create the adapter which will work as a bridge between the PayPal classes or the Stripe classes and the payment gateway. Okay, and then the client can use it out. I will show you how you can develop this. I will go to the next slide to discuss advantage of it. So the first thing is code reuse, decoupling, single responsibility, and flexibility. So the first one is code reuse. Use existing tested code in new ways without altering it. So this is one of the example of adapter design pattern. It enables the decoupling. It also help in maintaining the single responsibility, and it also provides the flexibility. You can easily add or replace the component by writing new adapters. So these are the advantage of it. Now I will go to the next slide to discuss about the disadvantage. So the two disadvantage I have listed down. One is the increased complexity, other is the overuse risk. So this adapter design pattern will increase the complexity of your code. So you have to see if there is a requirement of adapter design pattern in your application or not. If there is a requirement, then only implement it out. Otherwise, it will unnecessarily increase the complexity of your code. Okay, and also overuse risk. If overused, can lead to a system with too many adapters, making it harder to maintain. So these are the two advantages of it. I will go to the next slide to discuss where it is used in the real world application. So you can use in the legacy system integration that we already have discussed, and API wrapping. Okay, I will go to the next slide to discuss key takeaways. The adapter design patterns bridges the gap between the incompatible interfaces. It's particularly useful in integrating the third-party APIs or legacy system or modularizing code. And the third one is write adapters only when needed, ensuring the system remains clean and maintainable. So these are the key takeaways. Wherever it is required, then only implement the design pattern. Okay, so this was about the adapter design pattern. Now we'll come out of it and go to the IntelliJ, create one simple application, and then we'll try to develop this adapter design pattern. So come here and go to the file project, and let's say adapter design pattern. Okay, I'm selecting the Maven. I'm not creating a Spring Boot application. You can simply create any Java application. We are creating the Maven here. In the art type, we are just choosing this quick start and just create it out. Wait for few seconds. It will take few seconds of your time to do the necessary configuration, and then you can start doing the development. Okay, so just load this Maven project and wait for it. Till then, what I will do, I will tell you what we are going to develop here. So I will show you. Okay, how to use it. So here you can see. Okay, it is decorator. Will come up above. So here we are going to take the example of this payment gateway. Okay, so let's say in your application you want to develop a payment gateway. Okay, and the user or the client should use the payment gateway to do the payment. Okay, and in the payment modes you have different payment options like PayPal, Stripe, Razorpay, and this PayPal, Stripe, Razorpay payments are not compatible with the payment gateway. Then with the help of adapter design patterns, we'll try to make this payment tools compatible with the payment gateway. That is what we are going to develop here. So go to this IntelliJ, and we already have created this application. It is working now, and the necessary configuration is done. If you go to the source main Java, here we are inside our application, and now what I will do, I will try to create one interface called payment gateway. So let's say we are going to create the interface payment gateway. Okay, and in this interface, let's say we have one unimplemented method, which is, let's say, void process payment. Okay, and we are passing some amount here, and that's it, double amount. Now I'm going to create two classes, let's say Stripe and the any Razorpay or the PayPal you can use. So let's say Stripe payment, and let's say this class has one method which is doing the payment, which let's say its name is make transaction. Okay, so public void, and let's say make transaction. Here we are just simulating the scenarios, and then we'll see how we can use the adapter design pattern. So double amount, and then we are printing something inside this. Let's say out, and let's say we are printing that processing payment of this much amount. Okay, processing payment of amount this using Stripe. Okay, this thing you can also do amount of rupees, let's say payment of rupees this using Stripe. And similarly, I'm just going to create the other class called, let's say, PayPal. So PayPal payment, and this is also having some method which will try to do the payment. So let's say its method name is pay. So public void pay, and it is also expecting one amount, let's say double amount, and let me print something like processing payment of amount this using this. Okay, processing payment of rupees, and then we have to provide the amount here using PayPal. Okay, we are good. So these two classes having two different methods for the payment. The PayPal has pay method and the Stripe has make transaction method. But we want to use payment gateway to do the payment. Through payment gateway, clients to do the payment, and we can use or we can select any of these payment techniques, or you can say tools like PayPal or the Stripe. But as of now, you can see that if you go to these classes and if you want to implement the, let's say if you want to implement the payment gateway here, then you have to override the process payment class, and using this only you can do the payment. You cannot use this already existing pay class of the PayPal, right? Then how we can design a system that will help us doing the payment using the PayPal payment pay method only if you are selecting the PayPal, or Stripe payment make transaction method only. There comes the picture of adapter. The adapter will come in between the payment gateway and these classes, and that will do the real bridging between them, and then we can finally use internally we can use this make transaction and the pay method of this PayPal or Stripe to do the payment. So how we can do that, I will show you. So for that you have to create two adapter classes. Okay, so let me try to create that class. Let's say it is PayPal adapter, and this class would be having it should be implementing the payment gateway for sure. Okay, and if it is implementing the payment gateway, we have to override the process payment method of the payment gateway. So let me try to do that. And here what we are going to do, we are going to use the object of PayPal payment. Okay, so let's say private PayPal payment and we are invoking the constructor here of the PayPal adapter. So public, you can also do one thing, you can right click here, go to generate, and then you can choose this. Okay, and you're good. The constructor is created. Okay, now what we are going to do, we are going to use this object which is PayPal payment and call the make transaction inside this process payment. So use this PayPal and then call the pay method of the PayPal, not make transaction. Okay, and just provide the amount and we are good. Okay, so you can see that internally we are linking this PayPal payment using this PayPal adapter inside this payment gateway method which is process payment. Okay, now we can directly use this payment gateway to do the payment. Internally it will do the payment through this PayPal or the Stripe only, but now the user can directly use this payment gateway to do the payment. Okay, so this is what the adapter does, and this is what we are doing here. Similarly, you have to do for the Stripe as well. So let me try to create the class called Stripe payment adapter or Stripe adapter, something like that. It should also implement the payment gateway, override the method, and here also you have to create the Stripe object. So Stripe payment object is created. Now you have to invoke the constructor here. So right click, generate, and then go to the constructor, click on OK, and we have the constructor which is using this Stripe payment. And now we can go to the process payment of the payment gateway which is implemented inside the Stripe payment, and use this Stripe payment to call the make transaction method, pass the amount. So this is also binded. Okay, now let me create one client demo. Okay, and here let me have this main method. Now what we are going to do is we are going to see how the this adaptation, or you can say adapter design patterns works. Okay, so let me try to do that. So here what we are going to do is we are going to create the object of this PayPal payment, pass it out in the this PayPal adapter, and using the payment gateway we can process the payment. Okay, we are not going to use the PayPal payment or this Stripe payment independently. So like you have to create the object of the payment gateway only. So let me try to show you payment gateway. Okay, PayPal gateway, sorry, gateway. Here let's say new PayPal adapter. You need to pass the, if you go to the PayPal adapter, you can see you have to pass the PayPal payment object. So for that, let me create the PayPal object here. It is PayPal payment. Copy this, paste it here, and then with the help of this PayPal gateway, you can call the process payment, pass the amount, let's say 2,200, something like that, and should be double. Why we are passing it as a string? Let me remove this. Okay, so you can see that with the help of payment gateway only we are able to do the payment. Okay, and we are able to bind the PayPal payment class which has the different payment method, which was not the same as payment gateway. If you go to the PayPal payment, you will find that here we have the pay, and if you go to the payment gateway, we have the process payment. So we have to bind this two, and that is what this PayPal adapter is doing. If you go to the PayPal adapter, you can see that we are overriding the payment gateway, and we have the overridden payment gateway method. Here implementing the payment gateway, we have overridden payment gateway method, which is process payment, and inside this we are using the PayPal payment pay method. So we are binding it out, and the client is able to use the process payment, but internally it is going to the PayPal, right? So this is how adapter works. It will bind the legacy class with the new classes, and this is how you can do the binding. Now if you'll go to the client demo again, here you can see, and let me try to run this out and then see what it is doing. If you'll go to this, okay, we are printing something, so it will print. So you can see the processing payment of rupees this using PayPal. Even though you are using the payment gateway process method, it is going to this PayPal and then doing the payment. Now we are able to bind it out. But when we were trying to implement the payment gateway inside these classes, we have to use the process payment method directly. But here we are not doing. So this is how you can do the binding. And this is, let me try to again show you the example of the Stripe one. So let's say Stripe payment, you have to create the object of Stripe payment. Now payment gateway, use the Stripe payment, and here you can use the adapter. That's a new Stripe adapter, pass the Stripe payment, and with the help of Stripe gateway, you can call the process payment method and then pass the amount that you want to do. And you're good. Now let me run this again to show you. So this will do the payment using the Stripe. So this is how you can develop an adapter design pattern that will bind the two interfaces between each other, or that will work as a bridge between two interfaces that are not compatible. This is about the video, guys. If you like the video, please hit the like button and please subscribe the channel for more such content. Thanks.